Welcome to our maths class. Winding up on financial mathematics, I'm looking at amortization and sinking fund. Let's start. What is amortization? When borrowing a sum of money from a bank or a building society, it is usual to repay it by a series of regular equal installments. Those regular equal installments are called annuities. The present value of the series will be the same as the amount borrowed. This is the reason why you can use the annuity ideas on calculating amortization. And in this regard, we are going to be using the present value of annuity formula, which is PV of annuity equals to the annuity. In this case, the P is the annuity, multiplied by 1 minus 1 plus R to the power negative n over R. The ordinary annuity formula, A, which is the sum of money in the account after a period of time, is equals to the annuity 1 plus R to the power n minus 1 over R. This is going to be used for the sinking fund calculations. We'll come to that part later. Let's look at an example. Chisha wishes to borrow a sum of money to buy a house. She wishes to repay exactly 2,500 a month for 15 years at the rate of 13.5% compounded monthly. Find how much she can borrow. So how much she can borrow is going to be the present value of the annuities. What's the annuity? She wishes to pay 2,500 every month for the next 15 years. So the 2,500 is the equal installment that is going to be paid at that rate for that period of time. How much should she borrow? The amount borrowed is the present value of the annuity. So let's get to work. You need to bring down the present value of annuity formula to be part of your solution. Let's identify the variables that are given. We have R is given. R is 13.5%. That's a 0.135%. That's the annual rate. Compounded monthly, we need to divide by the number of months in a year. That's 12. When you do that, you should have 0.01125. What else are we given? The question, we are given the period N. We are told N is 15 years, but compounded monthly. So it's going to be 15 years multiplied by the number of months in the year 12. That should give you 180. What else are we given? The annuity itself, P. In this formula, P is the annuity, and that annuity or equal installment is going to be 2,500 paid every month. So how much should be borrowed? How much should be borrowed is the present value of this annuity. So let's do this. So how much should be borrowed? The P, which is the equal installment to be made, is 2,500. The R, which is the period rate, is 0.01125. That's R. 0.01125. How long? How many periods? 15 by 12 months. That is going to be 180. So tap that in your calculator. You should have that in your calculator. So this, you have to follow bid math here. So you had, first of all, what is in the brackets, 1 plus 0.01125. That is going to be 1.01125 raised to power negative 180. Then you say 1 minus that answer, the answer divided by 0.01125. What you should have after doing that, you must have 77.022,731. Then finally multiply that So finally multiply that by 2,500. You should have your final answer as 192,556.75. And that's how much Chisha should borrow. If Chisha wishes to repay 2,500 every month for the next 15 years, and the rate of interest is 13.5%, Chisha can borrow 192,556. That's the amount borrowed. Let me just spice up a question by also talking about interest effect and how much will be paid back effectively. The amount paid in total, if Chisha is paying 2,500 per month for 15 years, is this one. So amount paid. Amount paid is going to be, there are 180 payments for the 180 periods, and each time Chisha is paying 2,500. So all you need to do is tap that in your calculator. If you tap that in the calculator, you should have 450,000. How much is he going to pay effectively? 450,000. So the difference between 450,000 and the amount borrowed, 192,556, is going to be interest paid. Wow. Let's look at example number 2. Example number 2. Lungowe borrows 11,250 to be paid in 4 years to buy a car. How much must she repay per month, assuming an interest rate of 7.5% or a year, compounded monthly? It was supposed to be monthly there, compounded monthly. This scenario is different. Now we are looking for the equal installment that should be paid. The present value of the annuity is the amount borrowed. And we are told that Longowe borrows 11,200, so that's the present value of the annuity. What would be the annuity? What would be the equal installment paid? So solution, bring down the annuity present value of annuity formula. There. Next thing, let's identify the variables that are given according to the question. We have the PV given, which is the amount borrowed, 11,250, amount borrowed. The rate is also given. The rate is 7.5. That's a 0.075. That's the annual rate compounded monthly. So you got to divide that by 12 months in a year. And after doing that, you should have your RR equals to 0.00625. What else are we given? Apart from R, are we given N? Yes, we are given N. N is the number of periods. We are told this is going to go for 4 years, but payments will be made monthly, per month, monthly. So it's the 4 years multiplied by the 12 months that make a year. When you do that, you should have the period equals to 48. So having done that, you need to substitute. Substitute. So we are looking for the P. The PV is given, present value is given. That's 11,250. R, we've calculated R, 0.00625. 0.00625. R 0.00625. What else? N, we know N is 48. There'll be 48 periods. So when you do that, tap that in the calculator, of course, follow bid mass rule. Follow bid mass rule. You are going to have 1.00625 raised to the power negative 48. Then you say 1 minus that answer. The answer you have divided by 0.00625. Having done that, you should get 41.3583 So what you're going to do is divide this side by that amount. So divided by 41 point, divided by 41.35837114. What you do on this side must be done on the left side as well to balance off the equation. So divide that side by 41.35837114. So when this divided into that, you are going to remain with P. This divided into that, your final answer should be, when you divide this into that, it goes, you remain with P on that side. If you divide this into that, how much are you going to get? If you divide there, you should get 272.01. 272.01. So, how much should she pay every month? How much must she repay per month? So per month, she's going to be required to pay that much to pay back the loan plus the interest on the loan. So again, you can calculate how much interest has been paid. All you need to do is multiply 272.01 by the number of months, which is the number of payments, 48, then minus the amount borrowed, 11,250. The difference is going to be your interest. Now let's look at the amortization schedules. Amortization schedule. An analysis of how each payment in the loan is handled can be given in a table called amortization schedule. The amortization schedule contains the following parts or components: the principal outstanding at the beginning of every period, interest for the period, payment made at the end of the period, and the principal repaid. So the whole idea with the amortization schedule is that when you calculate the amount to be paid, payment at the end of the period, interest is first of all subtracted from there. Then the remainder is what goes to repaying the principal amount. So we are going to see this unfold. The table you need to do must have 5 columns. The number of rows depends on the number of payments and periods that must be made. So let's go straight into our example. We have this question, of course, is coming from a past paper. This is December 2017. That's the DA 2. Mr. Walia borrows 5,000. Borrows 5,000. That's the present value of an annuity from a bank. He agrees to repay the loan in 6 equal payments at 5% interest per month. The 5% interest per month, this 5% is not the annual rate, it's the monthly rate. So there is no need of adjusting the 5%. It's the interest per month. You only adjust to the period rate if you are given the annual rate. Construct the amortization schedule showing how much of each monthly payment is used for interest and how much is used to reduce the unpaid balance. Solution. What you need to do for this particular question, you need first of all to calculate that annuity, how much should be repaid. That annuity, calculate the annuity first. How do we calculate the annuity? We use the same present value of annuity formula. Present value of annuity formula. Bring it down there. What's the PV of this annuity? The 5,000 that is borrowed. So how much should be repaid? That's the P. We need to find out how much should be repaid. So substitute in that formula. So substituting, the PV is the amount of the loan, how much is borrowed, that's the 5,000. R, the rate of interest is given as 5%. So that's a 0.05. It's a monthly rate already. So you have 0.05. How many periods? How many periods? You are told in 6 equal monthly payments. So N is 6. N is 6 monthly payments. So calculate that. You should have 1.05 raised to the power negative 6, 1 minus that answer, the answer divided by 0.05, that should give you 5.0756. 5.0756, 92067. 92067. So divide this side and divide on the other side. Divide both sides by 5.0756, 92067. Your P must be equals to 985.09. So that's how much should be paid every month for the next 6 months. Then you come to the table. So the amortization schedule, you have to memorize what will be in the table. The first column is for the period, then the next column, principal outstanding at the beginning of the period, interest for the period, payments that are made at the end of the period, and then the principal repaid. So the payments that will be made, you've already calculated the payments. That's the payments that will be made every period. So every period you have those payments that will be made. 6 payments. These are paid over the period of 6 months, and they are monthly payments. So just count those payments. They'll be the same payments for 6 periods. So let's start filling in the gaps for this schedule. What's the principal outstanding at the beginning of the period? Principal outstanding at the beginning of the period is the amount borrowed. How much was borrowed? 5,000. How much interest will be paid on the 5,000? Interest is 5%. So interest, R, you can even indicate it there. Interest, R, is 5%. So question is, what's the 5% of 5,000? 5% of 5,000 should be 250. Then, at the end of the period, 985.09 is paid. The first thing you need to subtract from this amount is the interest to be paid. So you say 985.09 minus 250. What remains is what will go to reduce the outstanding balance. So 985.09 minus 250, you should remain with 735.09. So how much will be the outstanding Amount at the beginning of period 2, it's the 5,000 minus 735.09. When you subtract, you should get 4264.91. Interest is calculated on this amount, 5% of 426491. That is going to be 213.25. You make a payment 985.09 minus 213.25. Your balance should be 771.84. That is subtracted from the outstanding balance, 4264.91 minus 771.84. You should have 3493.07. Calculate 5% interest on that. Your interest will be 174.65. You make a payment 985.09 minus 174.65. The balance should be 810.44. That's subtracted from the outstanding amount, 3493 minus 810.44. The balance should be 2682.63. 5% interest on that, you have 134.13. Make a payment, subtract 134 from 985.09. Your remainder should be 850.96. Subtracted from 2682.63, you should remain with 1831.67. Calculate 5% interest on that. That's 91.58. Subtracted from the payment, your balance should be 893.51. That's subtracted from the outstanding amount, 1831.67 minus 893.51. You must have 938.16. Calculate interest on that. The interest should be 46.91. 46.91. Make your last payment. Subtract that interest from last payment. The remainder should be exactly equal to the amount you need to repay, 938.16. If you have a pointing ways as a remainder, just round off to the nearest whole number. It wouldn't make any sense to maintain a 0.02. That's amortization schedule. Now let's look at the sinking fund. Let's look at the sinking fund. A sinking fund is a fund into which periodic payments are made in order to satisfy a future obligation. This is the amount of an annuity as opposed to the present value of an annuity in the case of a loan. And here's the formula you have to use. With the sinking fund, you are looking at not the present value of an annuity, but just how much an annuity will amount to. So instead of using the present value of an annuity formula, you use the ordinary annuity formula. And the formula is given as the total sum, or A, is equals to the annuity P multiplied by 1 plus R to the power n minus 1 over R. If you are doing a sinking fund schedule also, it has 5 columns. You have to be looking at the period, interest added, deposit made, increase in the fund, amount in the fund at the end of the period. So let's look at that example. The Board of Education wants to raise 200,000. So 200,000, that's the total sum of an annuity. They want to raise it over a period of 2 years to build a new block of classrooms. How much should be invested every 6 months into the sinking fund, paying 10% compounded semi-annually? So if you are raising 200,000 in 2 years and you are depositing in 6 months time, you will deposit twice in a year. So for 2 years you will make 4 deposits, and that's the size of your aim. The sinking fund is 10% annual interest compounded semi-annually. So that annual interest of 10% must be converted to the semi-annual period. So let's look at how our solution can look like. Solution. Find the variables that are given in the formula. The period is given in the question. The period is given. That's our N. 2 years. 2 years multiplied by payments are made twice in a year. That will be 4 times. What else? ARA is given. ARA is 10%, 0.1 compounded semi-annually divided by 2. That is going to be 0.05. What else do we have? The sum of money we want to raise. The organization wants to raise 200,000. So let's calculate how much should be deposited, and then we bring that in the schedule. So get that formula. What are we looking for in the formula? We are looking for P. So our A, the total sum, we are looking at 200,000. P we don't know. We know ARA. ARA is 0.05. We also know N. N is 4. Okay, so the rate there is 0.05. 0.05. Just there, 0.05. So if you tap that in your calculator, when you multiply that, you should get 4.31. 4.31, 0125. So divide both sides by that amount. Your P should be equals to, dividing both sides by that amount, the P is going to be equals to 46,402. 46,402.37. So that's the eco investment that should be made, or eco deposits that should be made for the next 4 periods. So you can bring in that one to be the deposits there. Every 6 months, deposit that. And at the end of the period, we should have 200,000. So you know what should be there at the end of the period? We want to raise 200,000. That's what should be there. So let's start. For period 1, what we have nothing. Interest added, because interest is only added after a period of 6 months. So at the beginning of the period, there will be nothing for the interest. Then you make the deposit. What will be the increase in the fund? The increase in the fund is the amount you have deposited. That will be the increase in the fund. And what will be the total amount in the fund? The same amount you deposited. That's what will be in the fund. But at the end of the period, that money is going to earn interest. So how much interest? Interest is 5%. So 5% of 46,402.37 should be 2320.12. And then you make a deposit. So what will be the increase in the fund? The increase in the fund would be the interest plus the deposit made. So 2320 plus 46,402.37. That will be the interest. How much will be that? 46,402.37. And what will be the total amount in the fund? The total amount in the fund would be what was in the fund before and the increase in the fund. So 40, this is not supposed to be 46,402, this is supposed to be 48. When you had 2320.12 plus 46,402.37, you should get 48,722.49. So this increase in the fund plus what was in the fund before, that should give you 95,124.86. Then interest is paid on this amount in the fund, so 5% of 95,124.86, you should have the interest of 47,56.24. And then you make a deposit of that much. So how much will be in the increase in the fund? The increase in the fund is the sum of those two values. And how much would that be? 51,158.61. And what will be the total amount in the fund? It's what is in the fund before plus the increase in the fund. The total amount in the fund should be 146,283.47. What will be the interest? 5% of that amount. 5% of that amount is 7,314.17. Then you make a deposit. So this is going to be the increase in the fund, the deposit plus the interest, and that increase in the fund should be 53,716.54. What will be the total amount in the fund? What was in the fund before? 146,283.47 plus the increase in the fund, and that should give you the 200 we want to raise. That's how we calculate sinking fund, and showing the deposits and interests that are earned on the sinking fund. Well, that brings us to the end of financial mathematics topic. Please watch out for the other videos that I will do on financial mathematics, of course, involving revisions on financial mathematics. Thank you.